Hi everyone, and welcome back to Module 2, Part 2. So hopefully you've already had a chance to watch Part 1, and Part 1 was really to get the foundations of what is the normal distribution, and how does this function work in Excel. Today what we're going to do is we're going to dive deeper into the normal distribution. We're going to talk about how to find z-values, and we're also going to talk about how to calculate probability of word problems. So we're really going to focus on the application. And I know I had that question in Part 1. I was like, hold on, we're going to talk about application today in the lesson. So hopefully you've got the notes already printed off, ready to go, and you are ready to dive on in. At the end of today's lecture, we will be talking about the homework. And just a quick reminder to anybody, we had a great conversation earlier today, but if you have questions on the feedback, maybe you're not sure what the grader meant, or you're just not understanding what you need to correct, feel free to email me and I can look into the feedback and let you know how to read the assessment faculty's feedback and what you can improve. And if you have any questions on any of that, just let me know. I'm here for you. Just reach out via email. So we've already gone over the objectives, but you can look through that again. So what I want to do is I want to start off with a bit of review. So in Part 1, we introduced distributions, probability distributions, finding the probability that some value is going to occur. And we introduced a cumulative distribution, right? So it was either cumulative or discrete. And cumulative was like never ending, right? Infinite options to infinity and beyond. So we introduced these two types of cumulative functions, which were normal distribution and standard normal distribution. So what I want to do is I want to look at the similarities and the differences between these. Now remember, standard normal was the special type of normal distribution. Did we get everybody? Just making sure everybody's muted. Okay. So the things that they have in common that normal and standard normal both have is they both have a bell-shaped curve. So everything in the middle here is what they both have. So bell-shaped. So you're looking at that bell-shaped curve. Both of them had this. Now, what else did they have in common? They were both continuous variables, like we talked about, right? Infinite number of options. And the probability, how to find the probability, was we had to find the area underneath the curve. So finding that area underneath the curve gave us the probability. So if you thought of that, we didn't use calculus, right? We used that norm.dist function in Excel. That's what we used to find probability. So what are some of the differences between these two? Well, the normal distribution has an x variable, okay? Some x value that we're trying to find here, okay? And we use x for normal. Whereas a standard normal has a z value. And sometimes we call that z value the z-score, or the z-score. And for normal distribution, the mean can be any number. That has to be given to you. So the mean would be your mu, that symbol population mu. So they would give you the mean of the data set. Whereas standard normal is going to be a mean of 0. So it's always a mean of 0. How about the standard deviation though? Standard deviation of a normal distribution will be given as well. We don't know what that number is. And recall that sigma is your population standard deviation. Does anybody remember what the standard deviation for a standard normal distribution is? Does anybody remember that? Yay! Yes, very good, Cassie. So for a standard normal, the standard deviation would be 1. Okay, awesome. So that's kind of basically the differences between the two. You've got different variables. Normal is an X, standard normal is a Z. Your mean mean and standard deviation have to be given to you in the normal distribution. Standard normal, you assume the mean is 0 and your standard deviation is 1. Okay. Any questions about those two before we continue on? Okay, hopefully it was just kind of like a nice little review, reminder of what we talked about in part 1. So the first thing we're going to do in this week's lesson is we're going to learn how to standardize our variable. So what does that mean? If you're given a X value, okay, sometimes we want to convert it into a standard normal variable. So we want to convert it to a Z value. Because if it's in a Z value, we know that the mean is 0, the standard deviation is 1, and it helps us to do calculations and such. So the formula isn't actually too bad to convert an X to a Z, or what we call standardizing. Wow, I can't spell today. It's right there. Why am I trying to recreate the wheel here? Standardizing the value, okay? Standardizing the number. So what we do to calculate our Z value, Z score, we take our X value, we subtract our mean, whatever our mean is, and then we divide by sigma, our standard deviation that's given to us. Okay, so this is how we calculate our standard normal. X minus mu divided by sigma. Okay. Now Z scores are going to be rounded to 2 decimal places. Okay, 2 decimal places. And another thing to know about Z scores, I should probably write this down. Z scores are generally a number anywhere between like -3 to +3. Okay, anywhere on that number line between -3 and +3. It can be larger than that or smaller, but it's not as likely. So unlike probability, where you're always going to get a decimal, like point blah, 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 Z scores can be 0.89, but they could also be 3.1 or 2.6 or something like that. So that's generally what you're going to get for Z scores. Let's do some examples so you can kind of see the difference. So in this word problem, you take the SAT and score 1,100. The mean score for that SAT is 1,026 and the standard deviation is 209. What is your Z score? Whenever they ask, what is your Z score, you automatically have to jump to this formula, which gives you the Z score. Okay, that's the formula. That's how you know when to use the Z score formula. It asks you, what is the Z score? So let's go ahead and write down that formula. The Z score is equal to X minus mu all over sigma. I like to put parentheses around there to remind myself that I need to do that when I type it in Excel. So I need to go ahead and identify my variables and figure out what I need to plug in where. So let me start with mu. What does mu represent? This is why knowing the variables is so important. What does this mu right here represent? Mu is our mean. Very good. So if we're reading this sentence, what would be the mean? What do you think the mean would be? Yep, very good. The mean is 1026. They tell you what the mean is. So I know that mu is equal to 1026. Very good. Now, another variable that I need to plug in is sigma. What does sigma stand for? You can abbreviate it. You don't have to write it all out. Yep, your standard deviation. Very good. You threw in that population standard deviation. So do we know what our standard deviation is for this problem? Very good. They tell us, right? We're just picking out the information we need. The standard deviation is 209. So let's write that out there. Sigma is 209. So notice we've got our mu, we've got our sigma. The only thing left that we need to plug in is x. So x is your data value that they want you to convert. So the only number left is 1,100. That's our original data value that they want you to change into a z-score. So this would be our x value that we are converting, changing over. So now that we have our variables, let's go ahead and plug it into our formula. So it would be 1,100 minus mu, which is 1,026, divided by sigma, and sigma was 209. Now, of course, you could use a calculator to solve this fairly quickly, but I'm going to show you how to do it in Excel because we're doing everything in Excel, so let's go ahead and continue that trend, right? Any questions where I found that data from or any of the numbers? Okay, just let me know if you do have any questions on that. I'm happy to go back and explain. So I've got my blank Excel sheet, so go ahead and just pull up an Excel document, blank, ready to go. Now I'm trying to find my z-score. So in my tab, of course, any calculation, I start with that equals. And on the top, I'm going to type in parentheses my subtraction. 1,100 minus 1,026. And I'm going to divide it by my standard deviation, which is 209. Okay, 1,100 minus 1,026 divided by 209. Hit enter, and we get this decimal here, 0.35407. Now, as a reminder, we said we were solving for our z-score, so we have to round that to 2 decimal places. So what would that be rounded to 2 decimal places? Excellent, 0.35, excuse me, 0.35, yes. So remember, we look to that next when we say it's 4. Okay, we're not going to round, so 0.35. Let's go ahead and talk about what that means. So we got 0.35. That is our z value. Okay, that is our z-score. So what does that mean? What are we talking about here? Well, if we look at that normal curve, we're standardizing this value. So we're bringing it on the standard normal curve, where we're trying to convert it to a z value. So remember, with the z value, 0 is your mean, and then your standard deviation is 1, right? So if we were to look where our z value would be, 0.35, it's going to be very close to the mean. It's going to be about right here. So your SAT score was a little above the middle, okay? It was better than a little bit more than 50% other people, right? Okay, it'd be like right above here. So we can use that z-score to look and see how that compares to other students who scored in that test, that sort of idea. So that's the idea of z values. You're finding where on the number line you are compared to the mean. Let's try that again. If you're feeling good, go ahead and try this on your own. Otherwise, we're going to do this together. So you have a test score of 190. The test has a mean of 150 and a standard deviation of 25. Assuming a normal distribution, so an x value, what is your z-score? So remember, as soon as they say, what is your z-score, you know you should be using that formula, z-score equals x minus mu over sigma. So great question, Holly, and I'm glad you asked that. Holly asked, is z-score always a decimal or can it be a percentage? It is not a percentage. That's only when we talk about probability. And I know you're not the only one thinking that. We do not convert this to a percentage because this is a number on the number line. So if you look here for the z value, notice how it's a number line where you're going from -3 to like +3 basically. And you're seeing where on that number line you're located. So it's not a percentage, it's just a number on the number line. Does that make sense? So no percentages for z-score because you're looking at a number. Only for when we do probability. Yep, okay, great question. I love that you brought that up. So let's go ahead and figure out what we should plug in here. So I'm looking at this and I like to start with my mean and my standard deviation because it's a little bit easier. So can anyone tell me what I should plug in for mu, this symbol, the U symbol here that we call mu? Yes, very good. Mu stands for mean. Mean is 150. So we need to go ahead and replace mu with 150. Okay. What should I plug in for my sigma down there? What should we plug in for my sigma? Excellent. Sigma is standard deviation, and standard deviation is 25. See, I wasn't lying when I was like, it's good to have those variables memorized. There's a reason why I harass you guys about it, right? Okay, last one, x. What should I plug in for x? Perfect. X is my original value, which happens to be 190. So generally, that's how I pick out the information. I start with my mean and my standard deviation because it's easier to pick out. And then I move to my x value just to make sure I'm not confusing it at all. So let's go ahead and plug that in. So my x value is 190. My mean is 150. And my standard deviation is 25. So let's go ahead and plug that into Excel and see what we get. Did anybody already do that? .6, that's what I saw. Okay, let's see if we get the same thing. Equals 190 minus 150. I got to remember those parentheses, otherwise it's going to cause issues. And I did get 1.6. So excellent, excellent. Now a couple notes about this. I did see one person or a couple people put 1.60. That would be perfectly correct as well. That would be the same thing, and you could write it either way. Generally, we don't write the zeros after, but there's nothing wrong with it. It's the same thing, so it's not a problem at all. So if we were to look where this score would be on the number line, on that standard normal line, 1.6 would mean you are 1.6 standard deviations away from the mean. So you're about right here. That's where the 1.6 would be on that number line. So above the mean, you're not doing too bad, right? You scored pretty high, right? So that's good. Now, one other thing to note before we move on, and I wish I would have done an example like this, but you can have negative z values. You can have a z value that's like -1.3. That's okay. So don't be scared if you get a negative value for a z-score. You can have anything generally between -3 and +3. Sometimes you'll get more extreme values, but generally it's somewhere between there. Okay, so think of it as a number line and you're trying to find the number values. Any other questions on z-scores that you can think of right now? Okay. We have another example because why not? So this time we're looking at temperature, and we're looking at how the temperature is compared to other places. So the temperature is recorded at 60 airports in a region. The average temperature is 67 degrees Fahrenheit with standard deviation of 5 degrees. What is a z-score for a temperature of 68 degrees? So there is more information than you need here, and that may happen on your homework assignment. So make sure that you're working through what is the question asking, and then what information do I have? Is there any extra information that I could care less about? Okay, sometimes there's that extra information. So let's go through it. So it's asking, what is the z-score? What does that tell me? When it says, what is the z-score? I know I've got to use the z-score formula, which is x minus mu all over sigma. Woo! Okay. Now let's fill in the information. So the first variable that I'm going to is mu. So what would we put in for mu? What do you think would be our mu value? So I see a little hesitation. Everybody that's posted is correct so far. But just as a reminder, mu is your mean. Mean is the same thing as your average. So if we see average, exactly, Renee, we can assume that's the mean. So our mean, or our mu, should be 67. What's our standard deviation here? Yeah, and this one's not too bad, right? It says standard deviation, so there's no guesswork here. It's straight up standard deviation is 5. Now here's the part that can be a little tricky. We need to figure out our x value. Our x value is the number that we're trying to convert to z. So what do you think your x value would be here? What number are we trying to convert to z? Yay! Okay, excellent. So they're saying, what is the z-score for a temperature of 68 degrees? They're asking you to take 68 degrees and turn it into a z-score. So we take the 68, which is our x value, and turn it into z. This 60 airports business doesn't reflect ours. It's just the number of airports we used, which in our case does not affect us. Later on, we will be using the new variable n, which stands for the number of samples, and that would be 60, but it doesn't matter here. Just a little foreshadowing. So let's plug it in and figure it out. So x is 68, mu is 67, and sigma is 5. So let's go ahead and plug that into our calculator. Okay, 68, what'd you guys get? Minus 67 divided by 5. It should be 0.2. My guess is be careful of those parentheses around the top. Did everybody give that a look and come up? 0.2? Oh, that's okay. If that's the problem, I'm okay with that one. Okay, so our z-score is 0.2. So again, we could, write 0.20, but the 0 at the end doesn't matter. And again, if you want to think about it as the number line of your standard normal curve, you're talking about where are you on that number line. So let's go ahead and draw it real quick. We would be at 0.2, so a little bit more than 0. So approximately right here, that would be 0.2. So that would be our z-score. So a little bit above the mean. Okay, go ahead and try this next one on your own. Go ahead and see if you can find the z-score. So remember, it says, what is the z-score? So we're just going to write that formula because why not? Boop. Okay. Correct, Renee. You don't have to write that 0. So very good. Thanks for reminding me, Renee. Just as a reminder, 0.2 is the same thing as 0.2. Both are acceptable. Thank you for reminding me. I like to give those little hints in there. Okay, so perhaps you've given a moment to plug in your values. Let's see what we think. So what did we plug in for mu? I'm going to go step by step. Sorry, Kurt. I know you're excited. Mu is our average or our mean, which would be 350. Yep, so mu would be 350. What is our standard deviation here? Looks like it's given to us. 100, yeah. Okay, and then x is what we're trying to convert. So x is the original length, which is 80 pages. Very good. So I'm just going to plug that in real quick. Looks like some of you have already done it, and that's okay. No problem. I like that we're going to see a negative number here, just as a reminder that you're looking at the number line, so z-scores can be negative, unlike probability, which will not be negative. So let's see, 80 minus 350 divided by 100. Yep, I got negative 2.7, so it looks like you guys got it. Excellent, excellent. So again, that's my z-score. So if I were to graph it on my number line, let's use purple just to switch it up. It looks like it would be way over here. If we extend that number line a little bit more, it's almost to negative 3. So negative 2.7 would be right there. So pretty low below the mean or the middle of the data. Okay, pretty low to the other side, almost to negative 3. Okay, questions on z-score? Okay, it looks like you guys got it, so I love it. Here's kind of just to tie it all together. Here is a standard normal curve. You can see that the mean is 0, it's in the middle. And the standard deviation is 1, so it's like that yardstick, right? Every step away is 1 step. And the farther you get away from the mean, the middle, the less likely something is to occur. So if you see here, remember the probability that it will occur is the area above that number, and you can see that the area above that number gets smaller and smaller as you get further away from the mean. So it's less likely to happen as you reach to the ends. So as you go all the way to the ends, less and less likely to occur. The ones that occur the most are the ones that are closer to the mean, the middle of the data. So you see how much area is up there above the mean? Yeah, so it's more likely. So I'm just trying to show that connection between z and probability. Okay, so now that we talked about how to calculate your z, let's go into a brief review of probability. So remember, standard normal or your normal curve, you're looking at how much area is underneath that curve. So to calculate the area underneath that curve, we're going to use that norm.dist function. So we'll use that norm.dist function in Excel. And the probability that something is less than, so to the left of it, right? Okay, to the left of that value, we'll just use the formula norm.dist. Nothing too exciting there. Now, what if we're trying to find a value greater than that number? So everything to the right of that number, larger than. We're going to have to use 1 minus norm.dist. Okay, we talked about this last in part 1. So if you haven't seen part 1, definitely go back and rewatch it. And then if you want to find the value between two numbers, so doop-de-doop, maybe we want to find it between two z-scores or x-scores, you're going to have to find the probability of each and subtract the larger number from the smaller, or the smaller number from the larger, excuse me. And we'll go through problems like that. Is this all familiar to everybody? Does everybody remember this from part 1? Okay. We will talk about it more, but I just want to make sure everybody's kind of on the same page. So this is what I was talking about with application. So let's say an average light bulb manufactured by the Acme Corporation lasts 300 days with a standard deviation of 50 days. Assuming that the bulb life is normally distributed, what is the probability of the following events? So in business, and well, any business really, the idea that you need to understand what's the probability of something occurring, you would use this normal distribution idea to kind of predict that based on the average and the standard deviation of a survey of items. So in this case, they're looking at light bulbs and they're saying, okay, I know the average lifespan of a light bulb is 300 days. Average means mean, so I know that means the mean is 300. And they also found that the standard deviation was 50, so I know that the standard deviation is 50. Actually, I shouldn't be using, I should be using X bar and S, because that is your sample. So they're looking at a sample, and that's what they got from the sample. So I should be using those variables. It doesn't really matter, though, in this problem. Just wanted to emphasize that. So they're asking, what is the probability? So as soon as you see that question, what is the probability, or what is the percentage? I want a light to go off, and you're saying, okay, we've got to use the norm.dist function. That's what I want you to look at. Okay, what is the probability? I'm using norm.dist. So the first question is, what is the probability that an Acme light bulb will last at most 365 days? Now, does anybody know what inequality at most stands for? It's okay if you don't. It's not a big deal. Basically, at most means that's the largest number it can be, right? So all of my bulbs have to be smaller than that number or less than 365. So essentially what we're trying to find here is probability, so we use that big P, of our variable, which we know is normally distributed, because it says so in the problem, literally says normally distributed. And we know we're trying to find the probability that it's less than 365. So what function are we going to use in Excel to find the probability of less than? We're going to use that norm.dist, right? And remember, we need to put in our X value first. So what's our X value here? Our X value is what we're trying to find the probability of, 365. Our second number is our mean, which is X bar or mu. It doesn't really matter. I guess I used mu last time. It doesn't really matter. Let's change that back to mu. Everybody's using pencils, right? Doesn't matter. Okay, so 300 would be our mu, and our sigma is 50. And what do we always write last? True, yes. And you can see my really bad truth. So let's go walk over here to our handy dandy Excel. And Excel is going to find the probability that x is less than or equal to 365. That equal to does not matter because the probability that something's equal is 0. We talked about that in part 1. So equals norm.dist 365, 350, and true. So the probability is, I'm going to go ahead and make that a little bit larger, 0.9032 is correct, Kurt, and you rounded it perfectly. We are talking about probability. Probability gets rounded to 4 decimal places. So very good. That's exactly what you want to write. Is that what everybody got when they typed it in? Got one yes. Okay, perfect. Now, what is that as a percentage? Because we're back to probability. Probability can be expressed as a percentage. 0.9032 is 90.32%. So in other words, what they're really saying here is that the probability that you're going to get a bulb that lasts at most 365 days is 90%. That's a pretty good probability. As a manufacturer, you'd be like, okay, I feel pretty good about that. I can go on, my little advertisement and be like, usually, 90% of the bulbs last until 365. So, okay. Let's try the next one. So we're trying to find the probability again that an Acme light bulb lasts more than 400 days. So what inequality would more than be? So you're thinking more than is greater than 400 days, and you got the formula that you should use correct. When you have a greater than, okay, more than is larger than, greater than. You would want to use 1 minus norm.dist. What number would you write first? What's your x value? 400, yeah. Whatever number's in your probability statement. What do you write next? Your mu, which is 300. Your standard deviation comes next, and then always, that's true. My true eventually just becomes like blob after a while. Okay. So let's go ahead and find the probability that x is greater than 400. So what's the probability that a light bulb is going to last more than 400 days? Hint, it's not going to be a super lot. So 1 minus norm.dist, 400, 350, and true. Remember, if you forget what any of these should be, they tell you down here the order of x, mean, standard deviation, cumulative. So they tell you what to plug in. So what's our probability? So 0.0228. And we do round the 4th decimal up to 8 since the next one is 5. So 5 or higher, you round up. Okay, so let's go ahead and write that baby down. 0.0228, which is 2.28%. Excellent. Just moving that decimal 2 spots to the right. So in other words, how likely is it that a bulb is going to last more than 400 days? 2% is not very likely. Exactly, Vince. It's probably not going to happen. So this is good information for you to know if you were selling these light bulbs, right? You would want to know where the majority of the light bulbs are going to die out. So if perhaps you guarantee that a light bulb is going to last until so many days, you know that you're not going to have to pay out, right? Okay. If you guaranteed that the light bulb was going to last until 400 days, you'd be paying out a lot of money. So let's not do that. Hence why stats is so important. Yes. You want to save yourself money, right? Okay. Let's keep going. So in the next one, we want to find the probability that a light bulb lasts between 225 and 325 days. So that between means between. So let's write our probability statement. So our X value is between 225 and 325. So note what I did to set up the probability statement. I wrote the X in the middle, and we used less than symbols for both because it's saying that 225 is less than my value, which is less than 325. So it's in between those two numbers. So how am I going to find this probability of between? What am I going to use? What am I going to do? I could go back and double check. Between two numbers, I need to find the probability of each and subtract. So maybe you're setting that up already, but let's go ahead and walk through that. So I'm going to find the norm distribution of my larger X value first. So my larger X value is 325. And I use the same mean and standard deviation that I have been using. And I just subtract the norm.dist of the smaller number. So the smaller number is 225, 350, and true. Okay. So let's go ahead and plug this in. So probability that my X is between 225 and 325. Did anybody calculate this already? Norm.dist 325. My mean is 300. My standard deviation is 50 and true. We're subtracting the norm.dist of the smaller number, 225, 350, true. Does anybody agree with Kurt? Let's see. That I agree with you, Kurt. Yes, Cassie does? Yep, yep. Okay, awesome. Yay! Okay, so 0.624. Do we round up to 7? Yep, we did. Okay, perfect. So remember, 4 decimal places for probability. When you're using the norm.dist function, it always shoots back probability. So let's write that up. So 0.6247, so about 62.47%. So more than half likely that your light bulb is going to be somewhere between 225 days and 325 days. Good bet that your light bulb's going to be between there. Any questions on this problem that you had that you wanted me to clear up? I think I have a couple more. Oh, what's up?
Could you just click on your Excel worksheet in that key column one? It's not working and I don't know what it is.
This one?
Yeah.
Yep, sure. Absolutely.
Weird. Oh, I know what I forgot. Okay, Thank you.
Yep, no problem. Sometimes it's just a second glance or something like that. Any other questions on this one? Norm.dist function? Okay, let's go ahead. I have two more examples, so we might only get through one, but that's okay. We have a part 3, so good news. So again, let's look at the heights of adult males. So what if you want to know the heights of adult males? I'll get back to that, Kurt. And we know that they are normally distributed, so they tell us we are normally distributed, so we can assume that, with a mean of 70 inches and a standard deviation of 2. So we know right away that our mean is 70 and our standard deviation is 2. Good news. So they want to know what percent. So notice for a second that in this problem they ask for what is the probability, and in this problem they're asking for what is the percent. These ideas are the same. Probability and percent are the same. So if they ask for the percentage, percent, or probability, they're all asking you to do the norm.dist function in some way or another, okay? Kurt asked a great question. He said, can there be a possibility that we may be asked for z-score and probability? You will not be asked for z-score and probability in the same question. They will be different questions. Good question. Okay, so what percent of adult males are shorter than 65 inches? So they're asking what is the probability. Percent is the same as probability. They all start with P, so you're in the right mindset here. So my x value, my normally distributed x value, is shorter. So what inequality should I use there for shorter? Less than, yep. So less than 65. Smaller, shorter. Okay. So we're looking for what percentage of people should be shorter than 65. And I would tell you that this information would be helpful if, like, you were trying to start a men's warehouse or a business, right, selling things. You only want to stock so much of a certain item depending on what percentage of males are within a certain height, right? So thinking of the applications is important just to kind of get in the right mindset here. So x is less than 65. What function do I use when trying to find percent or probability? I use the norm.dist. Now it's a less than symbol, so do we just use it straight up? Or do we have to do the 1 minus? What do you think? For less than. Straight up. I feel like I'm talking like about a drink or something. Give it to me straight up. No. We're just, anyways. Hopefully this class does not lead you to be drinking, okay? I just hope that. Anyways, let's move on before this gets really weird. Norm.dist. What number comes first? Your x value, which is 65, you bet. What number comes second? 70. I almost wrote 70 down here. Okay. Which is your mu. 70. Okay. And then Holly knows what I'm going to ask next. Your next number is 2, because that is your standard deviation. And we already defined them over on the side, so we just reach over and grab them. And then, of course, we get true. Okay, go ahead and plug that in. Let me know what you come up with as soon as you calculate it. You may have already calculated it. So I'm going to move down here. So we're trying to find the probability that they are x is shorter than 65. So what's the probability that this man is less than 65 inches? Norm dot dist. Looks like not very probable, apparently. Yeah, yikes. 0.0062. Yep, that would be good rounding there. Excellent. So not even 1%. Less than 1%. So 0.0062, which is 0.62%. Now, I would say that you're not going to want to stock a lot of those clothes of that height because clearly there's not that many people that are that height, that amount of percentage. So thinking of applications there. Okay, let's look at the other end where taller men, okay? Approximately what percent of adult males are taller than 73 inches? So they're trying to find what percent or what's the probability. How would I write that probability statement? I'm gonna ask you guys, how would I write that probability statement? The symbols are right next to your shift key, if you're looking by there, on the right-hand side of your keyboard. The less than and greater than symbols. Perfect. Very good. Yay! Okay, that makes us so proud. Greater than 73. Okay, very good. So we need to find the probability that x is greater than 73. We want to put x in there to remind ourselves that x is our adult male that we're talking about. X is our variable, our normally distributed adult male that we want to find the height of. So what formula should I use? Should I use the norm dot dist straight up or should I do the 1 minus? 1 minus, yeah. You don't even need to write them, the rest of that statement. 1 minus norm dot dist. $73 is our x. Our mean is 70. Our sigma is 2 and true. Hopefully that's what y'all had. If you have any questions on that, just let me know. So let's see. Finding the probability or percent that x is greater than 73 is equal to 1 minus norm dot dist 73. 70, what'd you guys get? That's okay, Derek. Thanks for stopping in. Okay, so on the other end, really, really tall males, you're probably not going to have a ton of those, right? So 6.68%, yeah, not very high. Excellent, good, good, good. So 0.0668, which is about 6.68%. Okay. So still, men taller than 73 inches isn't, it's more common than being shorter than 65, but yeah, 6% compared to like about 0.5%. So something to think about. How about this? What percent of adult males are between 72 and 73 inches? So 6 feet and 6 feet 1. So how would we write that probability statement? What do you think? How would we write that probability statement here? What do we think? Between 72 and 73 inches. Great, Doreen. That looks perfect. Perfecto. 72 is the smaller number is written first. Yes, Stacy, excellent. Less than symbols used. 73 on the right. Everybody got it? I am happy. So again, the between is when you're finding the probability of both and subtracting. So let's go ahead and find the probability of the larger number, which is 73, and subtract the probability of the smaller number here. 72. Okay. Any questions on how I set this up? Just let me know. Otherwise, go ahead, type that into Excel. Make sure you get the same thing. I'm like dying of sweat over here because it's Illinois and it went from like 50 degrees yesterday to now it's like 90 degrees and I don't know what to do with my life. I can't decide what's happening. Anyways, you all really needed to know that, I know. Come to Minnesota, it's cold. Yes. Okay, so some people know. Melissa understands how I feel right now. Maybe some of you watching know. How cold is it in Minnesota, Doreen? In the 40s, yeah. And the thing is, I know I shouldn't complain because I know it's going to get super cold soon, like it's going to get in the 40s. But I feel like I want sweater weather right now. Come back to me in January when I'm dying from the negative degree weather. 95 here in Georgia. Oh gosh. 39 in North Dakota. Oh my goodness. Okay. I'm sorry, Amanda. I wish I could give you some of my heat. That sounds amazing. I'm super jealous of mid-70s. Okay. So back to probability. This is what we all got. 0.0918. Does that look about right? Yes. Vince, we're all moving in. He's like, that's okay. Can you do my homework for me? And then that's fine. Okay. So boom, we're looking at adult males. We've got some probability here, 0.0918. So this would be 9.18%. Woohoo! So not a huge portion that's between 72 and 73 inches, but right there in between those two values, those heights. So what I want to do is I want to be respectful of everybody's time, and I did schedule a part 3 for Wednesday at 1 p.m. Central. And what we're going to do in that class, just so you know, like, it's worthwhile, is we are going to go through one more example, but then we're also going to introduce talking about how to find a number, a sample number given a certain restriction. Or did I remember that right? Hold on. Let's look up what we're going to talk about because my memory is apparently not that great. Okay. So in part 3, we are going to talk about, we're actually going to talk about, I was thinking of module 3, sorry about that. We're going to find the z-score given a probability. So we are going to work with the idea of what happens if you're given a probability and you have to come up with the z-score. So we will work on that on Wednesday. But for right now, just to tie everything that we've talked about so far together, to find the probability or percentage, those are the same thing, you use norm.dis. This is one where you're rounding to 4 decimals. Your number, your probability should be a number between 0 and 1. It should not be negative. It will not be like 3.7 or anything like that. It will be a number between 0 and 1. You change it to a percentage like we did with like the 9% or the 0.6% or something like that, okay? So that's the idea of probability and percentage. We also looked at how to find the z-score. That z-score was on the number line, and we called it normalizing our variable, or finding the z-score. To find the z-score, we use this formula, x minus mu divided by sigma. We rounded the z-score to 2 decimal places, and it's just taking your x value and turning it into a z, or standardizing it. So what I want to do is I do want to talk about the homework. So this week is a little bit different. Deliverable 2, basically what they're doing here is they're saying, you're a tutor. Congratulations. I know you always wanted to be a tutor. Maybe you already are. I know I have some tutors on here. But you're tutoring Frank, and Frank needs your help and your wisdom and your guidance. And he's trying to work on this Word document. And in the Word document, he's got some incorrect answers, he's got some partially finished work, and he's got some blank questions. He needs you to go through the Word document and help him fill it out so he knows what to do on his own. So here is the Word document, which I've already downloaded. Let's zoom in. Okay. And here's the key for all the problems. If there's like a little I in front, that means it's incorrect. He did it incorrectly and you need to correct him. P means it's partially finished. Partially finished means the student's answer is correct so far, but you need to show the rest of the work. B is like, it's blank, he didn't know what to do, you need to do it. Okay. So number 1, assume that a randomly selected subject is given a bone density test. Those tests follow a standard normal distribution. So hint, 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 you know it's standard normal. Think about what you know when you talk about standard. Find the probability that the bone density score for the subject is between negative 1.53 and 1.98. And the student started to answer it, but you need to like work through it. And if you want to, just answer this question like you normally would. Okay? Just answer it here. Go through the steps on what you would do to solve it. You don't really need to take the student's answer if you don't want to. Be like, I have this easier way, Frank, of doing this, blah, 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 and just go through and explain how to do it. For number 2, you're looking at the U.S. Air Force, and they require that pilots have a height between 64 inches and 77 inches. So they have to fit in the cockpit, right? If women's heights are normally distributed with a mean of 65 inches and a standard deviation of 3.5, find the percentages of women that meet the height requirement. Great question, Cassie. So you're trying to find the percentage. What does percentage mean? What's another word for percentage? You can answer this question. Sorry. Probability. So Cassie asked a great question, and I'm glad you brought it up. To do these calculations, you need to explain what you would do here, but you need to create a new Excel document. So it should be like, just pull up a blank Excel document. Make sure it's blank, and just type in your work here. So of course you can say you would do this in Excel, but make sure you're turning in that Excel document as well so that your graders can see your work. So Excel document counts as your work. Does that make sense? So, sorry, I just read those comments. It was cracking me up. Okay, so yes, you do need to turn in that Word document and your Excel workbook. Back to the homework. So you're finding the percentage, which is the same thing as probability. So you can do number 2 so far. Number 3, you're trying to find the z-score of the beats per minute. The student has answered this way. It is incorrect, which is what that I means. You need to correct it, tell them what they did wrong, and then how to do it correctly. So basically, tell them what they did wrong, and then how to correct it here, and then give the correct answer. Number 4. So number 4, you can do. It says, what is the cumulative area from the left under the curve for a z-score of negative 0.875. Let's talk about this one. Let's break it down. What is cumulative area? What does the area underneath the curve represent? What's that area under the curve? What did we talk about earlier? The area under the curve is the probability. So in other words, they're asking us, what is the probability from the left? If you think of inequalities, to the left would be what inequality? To the left, or from the left is the same idea. From the left, what inequality would that be? It would be less than. It would be less than. It would be negative if you're thinking about it that way. Yeah. So basically they're asking, what is the probability that it's less than negative 0.875? So they're giving you a z-score. They're saying my z-score is negative 0.875. Find the probability that it's less than. That's essentially what they're saying here. Okay. It's just using different terms to talk about the same concepts that we looked at. Now, they also ask, what is the area on the right of the z-score? So what probability do you think you're going to want to find? So area, again, is probability. So what probability do you think you're going to want to find? Greater than this z-score here. So you can go ahead and tackle number 4. Do not do number 5. We have not talked about it. If you want to peek ahead to part 3 in your notes and work through that idea and using the norm dot inverse, you can try number 5. Go for it. Okay. My suggestion is to wait on number 5 though. You can take it or leave it. I mean, I'm not going to steer you wrong. Okay. Number 6, basically they're talking about manhole covers, bloop, 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 bloop. And they're talking about different things. And they're asking what percentage of men will fit into a manhole cover. So if there's a minimum of 22 inches, they actually tell you what you, 22.5. This is what I get for not reading the whole entire thing and just skimming. See, don't skim. Skimming is bad, as I just demonstrated. Let's just read this together. Manhole covers must be a minimum of 22 inches in diameter, but can be as much as 60 inches. So 22 to 60 inches, okay, manhole cover. Men have shoulder widths that are normally distributed with a mean of 18.2 and a standard deviation of 2.09 inches. Assume that a manhole cover is constructed with a diameter of 22.5 inches. Okay, so diameter is how far from each side the manhole cover. So if you think of a circle, 22.5 would be how far across it is. Now, they want to know what percentage of men, so what's the probability that a man would fit into this manhole that's 22.5 inches. So think about what that would mean, and they've started out correctly here, so you can kind of go off of that. So just keep going from that, in other words. So you can actually answer all the questions so far except for number 5, unless you want to peek ahead to Wednesday's lecture. So give that a try. On Wednesday, what I'll do is I'll do that extra practice problem. We will talk about finding the z-score given a probability, and I'll leave some time at the end if you guys want to work on this and ask me any questions. So if you pop into the live lecture at the end, I can also answer questions. I would not be recording that part, so you'd have to come live. So Casey, so great question. She says, for the step-by-step answers, do we include the formulas? How do we explain that? What I like to say is, imagine you're actually tutoring somebody. Okay, so we're all over at Vince's house in his nice 70-degree weather. How would you explain this problem to like Vince or Stacy, Cassie, or whatever? How would you explain this? So if you want to use step-by-step answers because that's what makes sense to you, use step-by-step answers. That's fine. As long as you include your work in that Excel document, either way. The requirements are just make sure you make it understandable. So what I would do personally is just like what we did here. Let me grab my PowerPoint. So like for this problem, right, I said, okay, we know it has to be shorter than, so we used less than. I knew that my X value had to be from that probability statement. I knew that my 70 was my mean because it said the mean is 70 inches. I knew my standard deviation was 2 inches. It was given in the directions. So since it's less than, I use my norm.dist function, plugged it into Excel, and we've got 6.62%. So similar to how like I explained it in class. That's always a great bet. Does that help? Okay. So you don't need like a ton, but just as long as you're clear and you're using that proper terminology, you're good. So remember, try module 2, try deliverable 2, work through those problems. If you have questions, you can always email me or come to Wednesday's live lecture and we can talk about them at the end. What else? You can meet with tutors or anything else that you want to. Usually it's best just to email me. That's what I should say. Okay. Other questions for me? Concerns? I'm going to go take a shower because I'm sweating so bad. Okay, great. Thanks everybody for coming. Sorry if there's a bit of a shine on the screen there. Okay, you guys have a great one. I will see you on Wednesday, hopefully. If not, I'll post the recording later that night. Bye, everyone. Thanks for coming. Bye.